Hello everyone, I'm Adam. In this problem, we're going to be finding the area of the surface generated by the curve made by our two parametric equations, x equal to 5 times cosine theta and y equal to 5 times sine theta, where our parameter theta is ranging from 0 to pi over 2 and the curve is being revolved around the y-axis. So to get started, we have a formula, namely the formula for the surface of a curve revolved around the y-axis, call it S, is equal to 2 pi times the integral from our limit, say a to b, of our parameter, times f of our parameter is theta, so we'll write theta instead of t, f of theta times the square root of dx d theta squared plus dy d theta squared and d theta, where the f of theta is the parametric equation of what x is. So x is equal to f of theta. All right, so all we have to do is find our dx d theta, dy d theta, and plug everything in, and then evaluate this integral. So our dx d theta, where x is equal to 5 cosine theta, derivative of x with respect to theta, is going to be negative 5 sine theta, and our dy d theta, where y is 5 sine theta, is going to be equal to positive 5 cosine theta. And now plugging all that in, so our area, S, is going to be equal to 2 pi times the integral, where our limits of our parameter are 0 to pi over 2. So f of theta, which is x, so we have 5 cosine theta, and times the square root of our dx d theta squared, so minus 5 sine theta squared plus dy d theta squared, so plus 5 cosine theta squared and d theta. Okay, so first we'll just go ahead and simplify underneath this square root if we can. So this is going to give us, say, 2 pi times the integral of 0 to pi over 2 of 5 cosine theta times the square root. So squaring negative 5 sine squared is going to give us positive 25 sine squared theta. And squaring 5 cosine theta will give us 25 cosine squared theta. So taking a look at this, well, we see we can, underneath the square root, factor out a 25. So this would give us 25 times sine squared theta plus cosine squared theta. And our sine squared plus cosine squared we know is equal to 1. So all we're really left with underneath the square root is 25. So this is going to be equal to, say, 2 pi times the integral from 0 to pi over 2 of 5 cosine theta times the square root of 25, which is 5. D theta. Oops, and we forgot our d theta over here as well. Put that in. Okay, so now we can bring our 5 times 5, which is 25, to the outside. So 25 times 2, we get 50 pi times the integral from 0 to pi over 2 of cosine theta d theta. So our antiderivative of cosine is sine, so this is going to be equal to, say, 50 pi times sine of theta evaluated from 0 to pi over 2. Okay, so we're going to have 50 pi, and just evaluating sine of theta at our upper and lower limits. So sine of pi over 2 is positive 1 minus sine at 0 is 0. So we get 50 pi times 1, which is just equal to 50 pi. So the area of our surface, there we have it, is equal to 50 pi. Thank you very much.